So today we're going to be talking about the law of conservation of matter and balancing chemical reactions. So first, let's discuss what the law of conservation of matter is. So it simply states that matter cannot be created or destroyed. So what this means in everyday language is that stuff that you see, it doesn't just appear out of nowhere or disappear into like the void or something. It's either made from other stuff when it's created, or when it's destroyed, it doesn't just disappear, it gets changed into other stuff. For example, you might think stuff is destroyed in like a fire, but it's not. It's just turned into, ash, and you have vapor that goes into the air, but the stuff is still there, it's just in a different form. And this is a very important concept in all of chemistry and science as a whole. Let's see here. So, and you'll see how this plays into balancing chemical equations in a moment. Okay. So let's look at a very simple chemical equation. This is the autohydrolysis, it's the autoionization of water. I don't think you'll need to know the name of this, but it's a pretty famous reaction. It's really simple. So it goes like this. You have H2O, like that, and that can form a hydrogen ion and a hydroxy anion. So, and you might not have seen this symbol before. This just means the reaction can go in either way. It means it's in equilibrium. But don't worry too much about that. That'll be covered later, I'm sure. So the main takeaway from this is that on this side over here, we have a water molecule. And on this side over here, we created two new molecules. But if you look, it's made from the same stuff that was already over here. So over here we have two hydrogen atoms, right there, right? And over here, we also have two hydrogen atoms. We have one right there and one right there. And then there's also one oxygen atom on either side. So you can see that nothing was made, nothing was destroyed, it was just rearranged. So that's whenever we do a chemical reaction, we're not making anything new, we're rearranging what's already there to form substances that have different properties. So that's a very, very, very simple case of balancing a reaction. Let's move on to something a little more complex. Let's see here. I wrote some down from your textbook. Let's see. Oh, let's write that a different way of stating that reaction. We can also say that a water, we have two water molecules. Then this can form what's called the hydronium ion. Plus the hydroxide anion. So this should look very similar because this hydronium, you can kind of think of this as a hydrogen ion that's bound to a water molecule. So we just saw that a hydrogen and a hydroxide comes from one water, and over here all that we've done is added another water, So we see that there's another water here. So this is also balanced. And by balance, we just mean there's the same amount of atoms and the same types of atoms on one side as there are on the other side of the reaction. But this can be written out a little more concisely. Instead of saying water plus water goes to form hydronium plus hydroxide, we can actually just say, we can get rid of this water here, and we can just say 2 times water. So this here, you probably have seen this in math by, if you had something like ETS, and you had 2 before the ETS, that 2 is what's called a coefficient. So coefficients are used in chemistry to balance reactions. So what you can do, how you read this, is you can think of this as saying 2 times the hydrogen and 2 times the oxygen. So it's 2 of everything here. You can kind of think like there's maybe a parenthesis here. And then when you're looking at this, I should have said this earlier, but these subscripts just mean that there's, whatever the subscript is, in this case 2, saying there's 2 of whatever's before it. So that's what that means. So these coefficients are useful. So when we go to balance a reaction, what we do is we change the coefficients. Because if we change what's in here, then we've changed the substances, and then we have a different reaction. And we don't want that. We want to have the same reaction. So when we're going to go balance some of these more complex ones in a moment, we're going to only change the coefficients. So you can change coefficients however much you want, but then you have to rebalance whenever you do that. So like, for example, I could throw a 2 here and a 2 here, but then this would have to be a 4 because I've doubled everything on that side, so I need to double everything on this side. So it kind of works like a math equation in that respect. Okay, so I think balancing reactions, you kind of know generally what you're doing. You're applying the law of conservation of mass to just make sure that there's the same amount of each type of atom on one side as there is on the other. So I think beyond that, it's really just better to get some practical application, because that's better than me just trying to explain the process without showing it. So let's see here. So let's take this. We have some silver, and that's going to be solid, and we're going to add some hydrogen sulfide. That's going to be in a gas. And then if we add some O2, or elemental oxygen, that's how it's found. When you breathe oxygen, you're breathing O2. So that's a gas. This goes to form, go on this side here, silver 2 sulfide plus water. Okay, so the first thing, you see this reaction, what do you do to balance it? Well, first, you count how many you count how many atoms you have. So let's make a list. On this side, we have some silver, we have hydrogen, we have sulfur, and we have oxygen. So how many silvers do we have? Well, let's see here. Let's write it with the black here. So we have 1, and then on this side we have 2. So we can already see that they're not balanced. Let's go hydrogen. We have 2 on this side, and we have 2 on this side. So that's good. At least those are taken care of. We have sulfur. We have 1 sulfur on this side, and we have 1 sulfur on this side. So that's good. And then oxygen. We have, let's see here, 2 oxygen on this side, and we only have 1 oxygen on this side. So the atoms that we're going to be looking for, I'm going to use this purple here to mark them. So we have to worry about the silver and the oxygen. Okay, so let's see, what can we do to this equation to get our proper amounts? Well, we have 2 silver over here, and we have 1 here. Well, we can add anything we want as a coefficient, so let's add a 2 here. So now we have 1 times 2 is 2. So that takes care of that. Well, now we have to take care of this oxygen here. So this might be a little more tricky because we have 1 oxygen here and we have 2 oxygen here. What you can do is just say 1/2, and then that would make that 1. This works, but a lot of times different textbooks and just the general convention is to use whole numbers. So I don't know if you've seen this in math, but you want to use n when n is over the real numbers. So that just means, let's see, so I'm going to just draw an arrow. This isn't a reaction, this is just me just drawing an arrow. So that means that n equals 1, 2, 3, 4, so on and so forth, out to infinity. It can be any of those numbers. So let's do it that way, or in a way that has a whole number. So I think that'll be more useful. So if we're not going to mess with this one yet, let's see what this one is. So we have 1 here, we have 2 here. So multiply it by 2. So now our oxygen is times 2, so that's 2. So we are even because we didn't multiply that by 1/2. So are we done? No. Since now we multiplied this, but we have to multiply the whole thing. So now we have 2 times 2 hydrogen here. So that puts our total hydrogen is now 4. So now what do we do? Well, we can multiply this hydrogen by 2. So now we have 4 hydrogen there, but now we have 2 sulfur. Okay, well now what do we do? Well, we can multiply this by 2. Well, then that gives us 2 sulfur, but then that gives 4 silver. So it looks like we're gonna have to double everything, and then that'll get us the whole number ratios, which makes sense. Because, let's see here, so if we put this will be 4, and yes, that should be all, I believe. Yes. Because if we were to have this half here, we would have had to multiply everything by 2 to put this at a whole number 1, if that makes sense. If that doesn't make sense, I can explain that more in like a different video or a Zoom conference or something. So now let's count all of our atoms. So we have 4 silver, okay. We have 4 hydrogen, okay. 2 sulfur, okay. And 2 oxygen, okay. So that's that side. Now this side over here, we have 4 silver. Let's see, and then we have hydrogen. We have 4 hydrogen. Let's see, I think I might be in the way. Then so that says sulfur. We have 2 sulfur, and we have 2 oxygen. So we can see that our numbers all match. So this is a balanced equation. Okay, let's do one that's a little more tricky. Okay, let's see, I wrote one down here. Okay, so let's take, we have aluminum sulfate plus calcium hydroxide. That goes to aluminum hydroxide plus calcium sulfate. Okay, and I excluded the phase indicators for what state the gas or the molecule is in, whether it's solid, liquid, or gas. So that's not really too important for balancing the equation. So first thing, this should be aluminum, not A. I don't know what A is. I don't think it's anything. So let's see. So let's say aluminum, sulfur, oxygen, calcium, and hydrogen. That's our atoms. So we have 2 aluminum. We have, let's see, we have 1 here, but then there's 3 of this whole group. So there's 3 sulfur in there, okay? And then there's 4, but there's 3 groups of 4, so there's 12. And then again here, there's 2 because there's that 2 out there. So 12 plus 2 is 14. And then we have 1 calcium, and we have 2 hydrogen. Let's see on this side. I'm gonna actually just redraw these here, just to make it looking a little easier. So we have 1 aluminum, sulfur we have 1, oxygen we have 4, 5, 6, 7, calcium we have 1, and then hydrogen we have 3. Okay, so what can we do on this? How do we even start? It's kind of a big mess. Oh, don't do that. There we go. Okay, well, what I like to do is start with the hardest looking one, the one that seems to be the most complicated, and solve that one first. And a lot of times the other ones will kind of take care of themselves if you do that. So I look at this and I say, which one looks the most complicated? Well, it's probably this one over here, right? We have 2 out here, this thing with a 4 in it, and then there's a 3 over there. So I'm gonna start here. So how do we get so that it's all balanced with this? Well, it has 2 aluminum here. So I'm gonna go ahead and put 2 aluminum there. And then we have this sulfate group here, this SO4. So what we can do, we can look over here and say, well, this has an SO4. So I have 3 here and 1 there. So let's just multiply this by 3. Okay, so now this is taken care of. Let's see what multiplying these things did to over here though. So now we have 2 aluminum, and then our, let's see here, and then our oxygen goes from 7 to now it's 2 times 3 is 6, 3 times 4 is 12, so that puts it at 18. Then we, let's look at the sulfur. It goes from 1 to 3, and then let's see, the calcium goes from 1 to 3, and the hydrogen goes 3 times 2 is 6. Okay, so we've changed it quite a bit here. So, excuse me. Now let's see, what can we do on this side, or how can we balance this out? Well, let's look at this calcium here. There's 3, and over here there's only 1. So let's multiply this by 3. Let's see what works. So now we have 3 calcium, so this is 3. And then we have 2 hydroxide units here. So if we multiply that by 3, then that'll be 3 oxygen and 6 hydrogen, or 6 oxygen, 6 hydrogen. And we already had 12 oxygen over here, so that puts at 18, 6 plus 12. And then the hydrogen is just 6 now. And so now if we look, let's see, we have 2 aluminum on both sides. We have 3 sulfurs. We have 18 oxygens, 3 calciums, and 6 hydrogens. So this is a balanced reaction. So it looked like it was going to be really hard, but all I did was balance this, and then these took care of themselves. Then I just had to add one thing over here, and I didn't even really have to mess with this one over here as far as changing it. Okay, let's just do one more that is a little lively, and that's a pun. You'll see why in a second, because we are going to do the reaction, or we're going to balance the reaction that is responsible for life. that is photosynthesis. Okay, so I'm sure if you've taken biology, you're probably well aware about photosynthesis. So let's see what it looks like from a chemist's point of view. So photosynthesis, as you know, plants use carbon dioxide, or CO2, and that's a gas. And then they react that with water. And then you know how we breathe is because plants give off oxygen when they do photosynthesis. So let's put that oxygen there. And it produces the plant's form of energy, or glucose. Got C6H12O6. So this here, so these are all pretty common substances. You know, oxygen we breathe, carbon dioxide we exhale, water we drink and use for a lot of things, and then glucose is in a lot of our food, especially plant-based food. So let's balance this reaction. So on one side, I should keep it, keep the same trend going where I start with the one color and then move to the other so you see the change. Okay, so we just have our three elements, C, O, and H. These are very common biological elements. And if you've talked about organic chemistry, then you'll know that organic chemistry is all about elements that have carbon. As you can see from this, that's, a lot of life processes have carbon. So on this side, we have one carbon, 2, 3 oxygen, and 2 hydrogen. Okay, let's look at this side. So on this side, we have 6 carbons, we have 8 oxygens, and we have 12 hydrogens. Okay, so now let's see, what can we do to this? Well, glucose here is probably is the most complex of all these. So let's start with that. So it has 6 carbons. Well, let's multiply this by 6. So then we have 6 carbons over here. Actually, I'm just gonna update this as we go. That might be a better way of doing that. Okay, and now this oxygen has changed. So now there's 12 oxygen here, because 6 times 2. And then we have 1 oxygen over here. So the oxygen is now at 13. Okay, so now let's keep balancing this one here. So this has 12 hydrogen. Well, if I multiply this by 6, that'll give me 12 hydrogen. So now my hydrogen is at 6. Then my oxygen here is 6, and then I had 12 here, since 6 by 2. So 12 plus 6, that puts it at 18. Okay. So now let's kind of look at this and let's take a step back and see if we have things that are the same. Oh, I'm sorry. This should be 12 because it's 6 times 2. That's math error on my part. So we could try to balance out this oxygen here, but we're already, to get the hydrogen, we already have 6 oxygen here. So if we do anything else to that, we're just going to get more, or we're going to mess up that the hydrogens are equal. But what we can do is we can make this oxygen, we can change this oxygen here. So let's see, how many oxygen do we need? Well, we have 6, and we want to get to 18 so they're balanced. So if this equaled 12, that would be great. Well, we can make it equal 12 pretty easily by multiplying by 6. So then this would then be 12 plus 6 is 18. Now we have 6 carbons, 18 oxygens, and 12 hydrogens. So now this is a balanced reaction. So, and if you can see there, if you start with the more complex ones, it's really easy at the end because we are normally down to just 1 or 2 elements, and a lot of times there'll be just a single element compound that will have that element, so we can just manipulate one thing instead of changing it, then having to worry about something else changing. Okay, So I think that's a good stopping point for now. So that was just some examples of how the law of conservation of matter plays into balancing reactions, and then some examples of balancing reactions. So I hope that was helpful. And yeah, feel free to leave any comments, and I'll either make another video to address those comments and work some more examples, or I can try to answer the comment just through the normal typing method. So yeah, leave any comments below, or shoot me an email, and I'll try to get back to you, or you can set up a Zoom meeting or something. So alrighty, well, have a good day.